Okay, so in every single Stoic problem, the first thing that you want to do is you want to balance the equation, okay? You want to balance the chemical equation. And lucky for us, I already balanced it for you guys, so you guys don't need to worry about it. So just make sure you guys have this jotted down somewhere, because we're going to need this for the actual math portion, okay? So step one, if you guys didn't know, for stoichiometry is you want to balance your chemical equation. And if you guys are still having trouble with that, please make sure you guys check that lecture where I go through a bunch of different examples and go through it step by step, okay? So I'll give you guys maybe 30 seconds to copy down the equation. Yeah, what's up?
Equal sign, like, let's go.
Uh-huh.
Like, the arrow.
Exactly, yeah. Yeah, it's a good way of thinking about it. Alrighty, so first step is balance. Now let's go to step two. The second thing that you want to do in every stoichiometry problem is you want to figure out what your starting number is, your starting chemical, and you want to figure out what you want to end up with, okay? So the starting chemical is very easy to find. All you have to do is look at the word problem portion, and you just want to look for the number that's in that problem. So if you take a look at this problem, what's the only number that you see in the word problem portion? Yeah, 15. So that's going to be your starting number. Okay. So your starting number is going to be 15, but we want to be a little bit more specific. So we're going to write that as 15 grams of CH4, and that's going to tell us the chemical that we are starting with. Okay. Okay, so our starting number and starting chemical is 15 grams of CH4. Even you said on the other side. Okay. All right. Now we're going to look for the ending point. So the chemical we want to find, and that's usually going to come after a phrase, how many or what is, right? So if you take a look at this problem, it's asking how many grams of CO2 we're going to make. So we're going to be looking for grams of CO2. So this is our ending chemical, okay? So that's how you can figure out what your starting chemical is and your ending chemical is. Okay. Alrighty, any questions about the first two parts? Yeah. Yeah, it's basically what the question asks you to find. So it's going to come after the phrase, how many or what is, something like that. Thanks. Yeah, so it's asking how many grams of CO2 will be produced. That's what you want to find. Okay. Okay, let's move on. So from there, once we know our starting and ending chemical, we want to find the molar mass for both of them. So molar mass is basically how much it weighs using the periodic table. So I'm going to do one of them with you, and then I'll have you guys try one on your own, okay? So the first chemical that you are looking for is CH4. So let's find the molar mass of CH4. Okay, so if you guys take a look at CH4, what are the two elements that make up this molecule? Yes, C and H, carbon and hydrogen. Good. Okay, so let's take a look at this molecule. How many carbons are inside of this molecule? Yeah, there's just one, because there's no number behind it. So that means there's one carbon. And how many hydrogens are there? 4. Okay, so just keep that in mind. The number only applies to the element right in front of it, okay? Okay, so you got 1 carbon and 4 hydrogens. Okay, and so if you guys find out how much that weighs, you can figure out how much the entire molecule weighs. So let's go to the periodic table and look at carbon and hydrogen. So you'll need your periodic table for today. So if you guys take a look at carbon, how much does 1 mole of carbon weigh? Yeah, 12.01, but I told you guys for carbon, you can just make it 12. So carbon is going to weigh 12. And if there's only one of them, carbon's going to have a molar mass of 12. Okay, now we're gonna go take a look at hydrogen. So if we take a look at hydrogen on the periodic table, hydrogen is 1.01, but I told you you can do 1 for hydrogen. And so if you have 4 hydrogens, what's the total mass of all the hydrogens? Yeah, 4. Yeah, 4 for the hydrogen. And then when you put them all together, the molar mass of CH4 will be 16 grams in 1 mole. Okay. So that's how you find molar mass. All you got to do is count up the elements and figure out how many there are, and then you can get your molar mass. Okay. Okay, so I'm gonna give you guys 2 minutes. See if you can find the molar mass of the other chemical we're looking at, CO2. Check with the person next to you, and then we'll go over the answer, make sure we're all on the same page, and then we'll move on to the last step. Okay, so right now what we're gonna do is we're gonna find the molar mass of CO2. Take about 2 minutes to do that. 2. Okay, so if you take a look at this molecule right here, how many carbons do you have inside of it? Yeah, just 1 carbon. Okay, and then the other element is O, and how many O's do you have? 2, good. Okay, so we can just copy off C right here. There's only 1 C, so that's gonna weigh 12. Now there are 2 oxygens, so we need to look at oxygen on the periodic table, which is 16, and since there's 2 of them, you either can do 16 plus 16 or 16 times 2, and that's gonna give you 32. Okay, so if you put them together, CO2 is going to have a molar mass of 44 grams in 1 mole. So this is going to be the molar mass of CO2. Okay. So those are the first 2 steps, and now we have every single number that we need in order to finish up the Stoich problem. Okay. All right, so before we do the last part, do you guys have any questions? That's chilling. Okay. All right. Yes. Yeah, I'm gonna leave this up here. Okay, so now what we're gonna do is we're gonna go into this fraction section. So I'm gonna give you guys a minute to copy down this setup. If you guys don't have it written down already, so take a minute to copy that down, because we're gonna be plugging in all our numbers into this fraction setup. Okay, so I'll give you guys a minute to do that. Okay, so whenever you guys start your Stoich problem, the first thing that you want to do is you want to copy down the starting number at the very beginning. So our starting number is 15 grams of CH4. So I'm just going to write down that it's 15 grams of CH4. Okay. So the first thing you want to do is you want to just put your starting number on the first blank. Okay. Okay, now I know that some of you guys are comfortable figuring out where to put the other elements, but I've noticed that a lot of people are switching up where to put their numbers. So I'm going to show you guys one more trick. If this is helpful for you, you kind of just got to memorize it, but you guys can use this method as well. So if you guys notice, our starting number is, or our starting chemical is CH4, right? Okay, what you can do is just put CH4 on the first fraction, so the top and bottom of the first fraction, and CH4 on the bottom of the second fraction. Okay, so those blanks will all be about CH4. And then our ending chemical is CO2. So you can just put CO2 on the other parts. Okay, so I color coded it for you guys so that you guys can very easily see where the chemicals go. But all these red spots are going to be for your starting chemical, and the blue spots are going to be for your ending chemical. Okay, so if you're having trouble figuring out where to put your numbers, you can just memorize this, and that will be an easy way to just kind of plug in everything from there. Okay. Any questions so far? Or are you guys chilling? Chilling? Okay. Hopefully. Okay, because everyone says that, and then when we have to do the problem on your own, everyone gets really stuck. Okay. All right, so let's go on to the first fraction, okay? So for the first fraction, our numbers are going to come from the molar mass of that chemical. So the molar mass, the first fraction is about CH4. So what we're going to do is we're going to use the molar mass of CH4 and plug in our numbers from there, okay? So if you guys take a look at the 16, it's next to grams, right? So if you look on this fraction, where's grams on this fraction, top or bottom? Bottom. So where should we put the 16? Yeah, we want to put it next to grams, which is on the bottom, so 16. And then if you look at the other side of the fraction, it's going to be 1 mole, so we put 1 mole on the top. Okay, so that's where we get those numbers. Yeah. Yeah, so we'll get to that. So let's go step by step. So let's go to the second fraction. So second fraction, your numbers are going to come from the balanced equation, the thing that we would have done in step 1. And all we got to do is look for the chemicals on the fraction. So we're going to look at CO2. Okay. What number is in front of CO2 for the balanced equation? Nothing. Nothing means that it's 1. So we're just going to put a 1 next in front of CO2 for the second fraction. Okay. If there's no number, it means that it's 1. Okay. Okay, let's go to the bottom now. There's CH4 on the bottom. We look at CH4 on the equation, and there's no number, which means that it's 1. So we're going to put a 1 on the bottom as well. Okay. So for the second fraction, the numbers are going to come from the balanced equation right here. All right, any questions about that part? We're almost done. Okay, last fraction, the numbers are going to come from the molar mass of CO2. Okay, and so very simple. All we got to figure out is where the grams are. So we got 44 next to G. So where should we put 44 on this fraction? Yeah, on the top next to grams, exactly. And then 1 on the bottom. And there you go, guys. That is your stoic setup. Okay. So all we got to do now is plug these numbers into the calculator. Now, the rule for punching it into the calculator is every single number that you have on the top, you're going to multiply. And every single number that you have on the bottom, you're going to divide. Okay, so this is the math rule for stoichiometry. Okay, if you want to throw in a third rule, you can basically just say ignore the ones. Okay, so everywhere you see a 1, you can just cross it out if that helps you. So you know you don't need to do anything with them. And the reason why is because if you multiply or divide by 1, it doesn't really change the number. Yeah. Yeah. What's up? No, you can ignore the ones. Because if you do 15 times 1, it's still 15. 15 divided by 1 is still 15. So you can just ignore the ones because they don't really change your number. Okay, so let's punch this into our calculator, guys, and we will be all done. Okay, so what we're going to do is we're going to start by punching in our starting number. Okay, our starting number is 15. So I'm going to plug in 15 into my calculator. Okay, if we go to the first fraction, there's a 16 on the bottom. So what should we do with the 16? No, the bottom we're going to divide. So we do 15 divided by 16. Okay, we can ignore all the ones. And then there's a 44 on the top. So what should we do with the 44? Yeah, this one we multiply. And we're going to get a final answer of 41.25. So your final answer is 41.25 grams of CO2. So this is your final answer. Yeah, you're going to have calculators on the test. Okay, guys, so that's stoichiometry. Again, went very much into detail, so hopefully this is helpful. If you guys do need help, make sure that when you're doing the problems that you refer back to this if you get stuck on any part. But if you're still having trouble, please make sure to double check with me. Okay. Alrighty, so make sure you guys have this all written down because we're going to be referring back to this for the last practice problem that we do. Okay, and your exam problem is going to look almost exactly like this. There's going to be one more thing added on the bottom, and that's what we're going to learn today. But when I'm grading your exam problem, let's say, for example, you fat finger the calculator and you press an extra button by accident and you get the wrong final answer. You're going to get points for every single one of the fractions as well. So wherever you see a number on this problem, you're going to get points for all of those. So if you get only one thing wrong, then it's not like you get the whole thing wrong. You're just going to lose points for that number. Okay, yeah. That's fine, as long as it's very close to the actual answer. Yeah. So we're gonna get, we'll probably get something different, but as long as your value is close, I'll accept it. Okay, good question. Any other questions on how I grade it? Okay, so we're gonna go into the new information for today, and then we'll do one very quick practice problem, and I'll get you guys started on the assignment. Okay. Okay, so today we're gonna be learning. You guys saw that the lecture was called TY/AY %Y. Well, I'm gonna tell you guys what those mean, and I'll tell you guys which parts you guys want to write down. Okay, TY stands for theoretical yield. And theoretical yield is the amount of a chemical you should make according to your calculation. So the key thing to write down here is that this number comes from your calculation. So whenever you do stoichiometry and you get a number, that number is called your theoretical yield. Okay, so make sure you guys jot that down. The TY is the number that you get from your calculations, from your stoichiometry. Yeah, this part down. Okay. So whenever you guys do your math, you guys find out how much of a chemical you should make from stoichiometry. That is called your theoretical yield, because that's what you make in theory, right? Based on your math. So that's TY. AY stands for actual yield, and actual yield is how much you actually make in real life. So when you guys did your experiments, right, you guys made MgO, that number, and then you guys weighed how much you made. That number right there, that weight is called your actual yield, and that comes from your lab or from your experiment. Okay, so one of them is theoretical, one is based on math, one is based on what you actually make. So theoretical yield and then actual yield. Yes. Yeah, it's the number you get from your lab. All right, and so the reason why we talk about theoretical yield and actual yield is because you're never gonna make the exact amount that your calculations predict. Those of you that finished the lab, you guys might have noticed that in the lab, you did your calculations for MgO, right? And it was different than the actual weight that you found on the scale. And the reason why is because nobody's perfect. We all make mistakes, and there's always issues when we do a lab. And so some of the issues that might come up, and you guys don't need to write this down, is you guys might notice sometimes the chemicals get stuck on your glassware or on the crucible, right? You can't get all of it. Sometimes you might spill a little bit when you guys are transporting. Some of these chemicals are really light, so even like air currents could move them out of the container. Or sometimes the chemicals just don't go all the way. They don't go all the way in the reaction, okay? And so because of that, and you're gonna want to write this part down, the number that you get for your actual yield is always going to be less than the number that you get for your theoretical yield, okay? So your actual yield will always be smaller. It will be a smaller number than your theoretical yield. Okay, so if your actual yield in your lab supposedly is bigger than your theoretical yield, that means it's impure. So basically you messed up. I'll remind you guys of this the next time we do a lab. So you guys don't need to write this part down, but just keep that in mind. Actual yield is always smaller than your theoretical yield, okay? Okay, so that's TY and AY. And then the last one is going to be %Y. Okay, and there's a formula for %Y, and so you're going to need to jot this down. We're going to be doing percentages a lot in this class, so I'm going to have you guys memorize this. But %Y is just going to be your AY divided by your TY times 100%. So you can either do it like this, or if you want to write it down like this, you can do this as well. AY divided by TY times 100%. And that's going to give you your %Y. Okay. And so that's all the new information for this unit. And this is all the stuff you're going to see on your test. So we're going to go over a quick problem. I'm going to show you guys what a full test question looks like. And then after that, I'll have you guys start your assignment. Yeah, what's up? Oh, good question. Yeah, don't punch percent on your calculator. Just multiply 100. The percent sign is just to write at the end of your answer. It's a good question. Yeah. And I'll show you how to solve all this in just a second. Okay. Yes. Yeah, you're always going to multiply 100% at the end. Okay. Any other questions? Okay, let's do a full length test question and then I'll get you guys started. So I'm not going to do the hard part with you, but your test question and your questions on your assignment are going to look like this. Okay, this is the question we did on the warm-up, so don't write this down. But for your test question, you're going to do that first part that we did, and that's going to be part A. So we're going to do our stoichiometry. Oh, I messed up right here. This should be 16. Okay, but you guys see how this is the exact same problem that we just did, right? Okay. Now, the number that you get at the end, which is 41.25. Okay, this number right here is the one that we got from our stoichiometry, right? And so this number right here that you got for your warm-up, let's label that. This is your TY, okay? So label that on your notes because this is the problem that we're going to be working with. Your TY is going to be 41.25. It's the number that you guys got from your calculations. It's what we did in our warm-up. So on your exam, you'll basically have to do all the stuff we did in the warm-up. That's going to be part A of that problem, okay? All right, so far so good? Chilling? Okay, so the new thing that we're going to be adding is this part right here, part B. And in part B, obviously we didn't do this experiment, but let's just say that we did hypothetically. So if you guys do this experiment in a lab, the problem says that you obtained 40 grams of product. Now, this number right here is going to be your AY, okay? Because if we actually did the lab, the problem is telling us in real life, we actually made 40 grams of product. So our TY, the number we get from our calculations, is 41.25 grams of CO2. And then AY is going to be 40 grams of CO2. Okay. It's that easy. All you guys got to do is read the problem, figure out how much you should have made, and then that's going to be your actual yield. Okay. All right. And then the last thing is the percent yield. So we're going to calculate for percent yield. So your percent yield is just going to be your actual yield. So we're going to take the number 40. We're going to divide it by the theoretical yield, the number you got from your stoichiometry, 41.25, and then we're going to multiply it by 100%. Okay. So let's punch that into our calculator. We're just going to do 40 divided by 41.25 times 100, and then that'll give you a final answer of, let's do 96, and then you guys can round it or you can not round it, doesn't really matter. I'm going to do 96.97%. If you guys do 96.96%, that's cool too. Okay. And that's going to be it. That's the new stuff. It's very simple at the very end. We just need to add in theoretical, actual, and percent yield. Okay. Alrighty. Any questions on the new stuff? Okay. And this is what a full length test question is going to be. So on your exam, I'm just going to give you one that looks basically exactly like this. I think one of the test versions is this reaction too. So if you have that version, then congratulations, that's how you balance it. Okay. All right, any questions? Are you guys chilling? Okay, so I'll give you guys the rest of the class period to work on the assignment. It's gonna be the TY, AY, %Y assignment. So make sure you guys do it on a separate piece of paper. Just a quick note, if you guys are comfortable balancing, then you guys don't need to show me the table for the balancing if it's easy to do. And then for the molar masses, you don't have to show me all the work for the molar masses if you don't need to. Basically, everything that I have here on the screen right now, this is the stuff I'm going to require. But anything other than that, it's just for you if you need to write it to help you as you solve the problem. But the minimum that you have to give me is this stuff right here. Okay? All right, I'll give you the rest of class period of work. Let me know if you guys want to check your answers or if you guys need any help.